Hello, hi everyone, welcome to my channel Samuel Flying Birds. In the previous class, we have studied about real numbers, introduction, and exercise 1 problems. In this class, we are going to study about the exercise 2 and the related topics. Here we need to do some revision of some terms and definitions related to our previous class. First one, composite numbers. Definition. A positive integer that can be formed by multiplying two smaller positive integers. It is a positive integer that has at least one divisor other than 1 and itself. For example, 14 as we consider, we can write 14 as 2 into 7. What are prime numbers? A prime number can be defined as a number that is divisible only by itself. Example, we can say 2, 3, 5, 7, 11. What is factorization? The definition of factorization is defined as the breaking or decomposition of an entity. We need to understand here that we are going to separate a term in 2 or 3 fractions or in a multiple fractions. Example, a number can be a matrix or a polynomial can be divided into a product of any other entity or factors. For example, find HCF and LCM of 12 and 18 by the prime factorization method. The given numbers are 12 and 18. We know that the factors of 12 and 18 are 12 equal to, we can write 12 as 2 into 2 into 3. It is nothing but 2 square into 3 power 1. For 18, we can write as 2 into 3 into 3 equal to 2 into 3 square. Therefore, the HCF of 12 and 18 can be written as 2 and 3 is equal to 6. We know that HCF is a smallest power which we are considering to find the HCF of a number in a given factor. For LCM, we need to observe the highest power of the given factor. For LCM of 12 and 18 is 2 square into 3 square is equal to 36. Exercise 1. For the first problem, express each of the following numbers as a product of its prime factor. For the first question is 140. Now we will see how we are solving the problem. A 140 is written as 2 70s, 2 35s is 70, again 5 7s is 35, 7 1s is 7. So the factors of 140 are 2 into 2 into 5 into 7. We can write it as 2 square into 5 into 7. For the next problem, it is 156. The factors of 156, we can solve it as 2 78s 156, 2 39s 78, 3 13s 39, 13 ones 13. Hence, 156 can be written as 2 into 2 into 3 into 13. We can also write as 2 square into 3 into 13. For the third problem, 3825. The factors of 3825 is 3 3 ones 3, 3 2, 6, the remainder 2, 2 7 21. Again the remainder is 1 2 5, 3 5 15. In the same way, we are doing 3 425s 1275, 585s we get 425, 517s we get 85, 17 ones 17. So the factors of 3825 are 3 into 3 into 5 into 5 into 17. We can write it as 2 square into 5 square into 17. For the next problem, 5005. Sorry, 5005. We solve it as 5 1001, 7 143s we get 1001, 11 13s we get 143, 13 ones 13. So the factors of 5005 is 5 into 7 into 11 into 13. For the next problem, find the LCM and HCF of the following integers by the prime factorization method. For the first one, 12, 15 and 21. We need to find the factorization of these three numbers. Coming to the first method, we know that the factors of 12, we can write it as 2 into 2 into 3. It is also written as 2 square into 3 power 1. For the 15, we can write it as 3 into 5. And for 21, we can write it as 3 into 7. Hence, the product of smallest power of each common prime factor is considered as HCF. So the HCF becomes 3. And the LCM is product of greatest power of each prime factor. We know that 2 square into 3 into 5 into 7 is the greatest prime factor of all the three numbers. So we write it as 4 into 3 into 5 into 7 is equal to 420. For the next method, for finding HCF of LCM of 12, 15 and 21, we go for the second method. In the similar way, we write the factors of three numbers as 12 equal to 2 into 2 into 3, 15 equal to 3 into 5, 21 equal to 3 into 7. Hence, the HCF is obviously 3. As we do separate factorization, we get the HCF as 3. For the LCM, we no need to go for the separate factorization. We can write all the numbers in a one column and we can write all the factors at a time. So the LCM is equal to 2 into 2 into 3 into 5 into 7 is nothing but 420. For the next problem, 17, 23 and 29. For the first method, we proceed. 17s we can write it as 17 into 1. 23 we can write it as 23 into 1. 29 we can write it as 29 into 1. The HCF is 1 in all the three numbers. The LCM is 17 into 1 into 23 into 29. It is 11339. Then coming to the HCF in the second method, we do the separate factorization method. 17 equal to 1, 17 into 1, 23 equal to 23 into 1, 29 equal to 29 into 1. In all the three numbers, we are having 1 as a common factor. So we consider HCF as 1. Coming to the next, LCM, all the numbers are being written in the same column and considered the LCM of all the three numbers as 17 into 1 into 23 into 29. We get the answer 11339. It is the LCM of all the three numbers 17, 23 and 29. Coming to the next problem, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. We need to derive the expression why it is called a composite number. So the first step, 7 into 11 into 13 plus 13. we consider the 13 is common in both the terms. So we write as 13 into 11, 7 into 11 plus 1. So 13 into 77 plus 1, 13 into 78. We can write it as 13 into 13 into 3 into 2. Since it has more than 2 factors, we write it as 13, 3, 2, 1, 13 into 78, that is 1014. It is a composite number. Now we consider 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here 5 is a common term in both the area. So we consider 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 1. 5 into, after multiplying the first term, we get 5 into 1008 plus 1. So we can write it as 5 into 1009. Since it has more than 2 factors, so the factors of the given expression is 5, 1009, 1, 5 into 1009. That is 5045. It is a composite number. Coming to the next problem. How will you show that 17 into 11 into 2 plus 17 into 11 into 5 is a composite number? Coming to the solution. 17 into 11 into 2 plus 17 into 11 into 5. It is given in the question. Taking 17 and 11 as common in the both terms, we get 17 into 11 into 2 plus 5. So we can write it as 17 into 11 into 7 is our number. So the number is divisible by 17, 11 and 7, and hence it is a composite. As composite numbers are those that have more than 2 factors. Thank you for watching this video. Please share, like and subscribe.